Hey, hello. Welcome to Flare's online builder workshop, the third session. So we've done quite some stuff beforehand. So we've seen what Flare is, learned some basic things about Flare. And last time we developed and created our own smart contract, made our own ERC20 token, and created it, put it to blockchain, deployed it fully, played around with it, and at the end also used the oracles, the thing that Flare has directly in it. So we've done a bit more theoretical introduction, we've done a bit more practical hands-on coding experience, and today we're going to see why this thing that we've used previously, so the oracles themselves, the pricing, why this is really important, and what else can Flare do about this, and why Flare is uniquely positioned to offer you great experience when using the oracles, and why Flare is uniquely positioned to not only offer you great development experience, but also offer you certain security guarantees that are, at least in my opinion, very important if you are developing in the blockchain world, and in general, very important if you want to do an application, a dApp that closely works on blockchain and is able to leverage everything that the technology has to offer. So today we're going to take a look at what the oracles are, why do you need them, and we're going to see a few things about how Flare does them, what is so specific about them, and not just why oracles are and why you need them, but we're going to also take a look at how you can use them and why a specific oracle is useful for a specific thing and why a specific oracle can give you a great advantage when programming on blockchain and what else you can now do. So what the oracles really empower. In the next few academies, we're going to dive deeper into them. We're going to see how exactly FDC, FTSO, and FSP function. Today, we're just going to look at the broader thing. Okay, so let's start. As usual, there's going to be a Q&A at the end, so be careful, listen carefully, ask some questions, and at the end, you might again get a surprise if you listen carefully and know how to answer some of the questions. Okay, so again, the image we've seen before. So blockchain. What's the main purpose of blockchain? So blockchain was designed to be secure. So from the very inception, the main idea of blockchain was to make sure that all the data you have there, anything you have can be specifically secure, and you can make sure that anyone can verify the whole chain. That's the main idea about the protocols we have, the main idea about the validator sets, the main idea about the whole decentralization principle. So if I create a block on blockchain and push it to the network, I don't have the power to do this. I can do it anyway, and everybody else can independently check that A, the block is valid, and B, I have the right to do it. So on Bitcoin, to prove that the block is valid, I need to mine it. I need to input some energy. I need to spend some energy to prove that I've made some commitments, I've made some calculations to make the hash small enough. On proof of stake chain, I need to stake some of my money, some of my tokens to have the ability, the right to propose a new block. And then people can say, yep, he has the right to propose this block. He's been randomly selected to, for example, propose that block, and we can choose it as the next block. But everybody can independently verify that the block I am proposing is still valid. That's the core principle. I'm giving you a block, but you can always say no according to a very specific algorithm, and you don't have to trust me on this block in any way. You can accept it or reject it. And this independent verification, not only of one block, but the whole chain of blocks, means that this immutability is inherited directly in the chain, which means that I can't change a simple thing in the beginning of the chain and then rewire the chain at a later point, because the whole chain would have to change. And it's very easy for me to check and verify the correctness, but very, very difficult to really change something. And one of the main problems here is, how do we get the data from the outside? Why from the outside? Well, you want to use something else. You don't want to use just a simple blockchain. You don't want to be encapsulated. You don't want to be limited to a simple and just a single ecosystem. You want to do something else. I mean, at the end, your apps, A, interacts with users, and B, you want them to interact with something else. And getting this outside data is not trivial. So you need to do something. You need to make sure that the data is secure, and you need to keep this ability to verify blocks after a certain point that are still in the blockchain without hampering the security assumptions. So this is the thing we're going to look at today. and search how different things solve it, and specifically look at how Flare is solving this, and why even after solving this, you can still use this in a relatively easy way without having to do some specific calculations. So how do you have a system when you can always verify something? And how do you get the data from the outside in it and still keep both the data and the chain fully secure? Okay, so data from the outside. Let's just speak about the data and why would you need it, where would you need it, and what are some of the problems that can come with it. So here are a few examples of data from the outside. So a simple data that you or your dev might want to use that is not directly available on blockchain is, okay, I want to execute a search query. I want to execute a Bing query, a Google query, whatever. I want to execute an API query. So the first thing is, how can I verify this at a later point? What if the results change? What if I'm not available? What if I'm not allowed to access this page? What if search results are somehow blocked? What if I get different results than somebody else? So you have to be careful about this. So even a simple search query is already complicated. And then if you go a bit down and want to be a bit more specific, let's say I want to query an API. Let's say I want to query a weather data API to have a dApp that allows people to insure their crops. And then according to the weather data, they can claim the insurance on top of it if, for example, there was not enough rain. And again, so you need to query an API. What if the site is down? What if the site changes? What if the site is blocking you? Or what if the site is temporarily overwhelmed? Or what can you do if the site is temporarily hacked and is providing you with false data, but you want to be able to source this data maybe at a proper quality level, and you want to source it multiple times? So here's also one problem. So you want to query an API. There's a bunch of questions you need to answer. Next important thing that you usually want to include in your blockchain and is usually very useful in your application is randomness. So let's say you want to source randomness from somewhere. Why would you like randomness? Well, people like to game, people like to gamble, people like to play around with randomness. You want to toss a coin, you want to play a poker game, you want to play some blackjack on chain when you can know that everything is verifiable and the house can't cheat. Well, you do need randomness. And how do you do it? Well, there are usually certain specific requirements you have about this random number. So it has to be non-predictable in advance. Otherwise, the guy who's playing against me on the other side of the table might be able to very easily predict what the next card is going to be and pretty much outbid me if that is profitable to them. So you want it not to be predictable upfront. You want it to be secret just until the end. And you want to know that this randomness cannot be tampered with. So you want to know that I can't bribe a validator to provide a bad random number. This is one thing. And still, once you get random, you don't really want to think about those things. You want to be sure that the blockchain, the whole system where you get this additional extra information, makes these things secure. And you just want to play around with them, develop with them. You don't want to tinker with some parameters, and you don't want to tinker with parameters, and you don't want to tinker with security assumptions too much. You want to make this as easy as possible to start, and then at a later point, only then do you want to open this and check the assumption. And the fourth example of Oracle we're going to take a look at is the price Oracle. So for example, a very specific data you want to get from the outside is the price of a non-crypto asset. So you might want to use an Oracle that is available on chain, for example, on some DeFi market, but that can be manipulated very easily, specifically for things with low liquidity. So let's say you want to source the price of something outside the chain. And again, there are a bunch of questions you need to be careful about before considering the proper Oracle. So let's say you source price from somewhere. Again, there's a question of trust. So do you trust the people that you source the price from? Is it going to be live long enough? Is it going to be refreshed often enough? And how can this damage me if I have a debt? So if you have a specific debt, for example, that trades with futures, you want to be sure that somebody who has opened a short position against you or who has somehow participated in this debt cannot interact with the Oracle in such a way to manipulate it. So again, you want to have this whole blockchain experience in security. So those are a few data examples. And usually when you work on blockchain, those things are not available directly in the Solidity. So your programming language does not allow you to query an API directly or source the price from somewhere directly or get randomness from somewhere directly. You have to get this from somewhere else. And we usually have an encompassing term for this, and that is oracles. So oracles are all those things you can get to, you can query to get you a specific piece of information that is usually a bit more difficult to get or not natively available. And what we'll see today, we'll check up on some oracles. Specifically, we'll check up on an oracle for randomness, how FTSO does it, how Flare provides it. We'll check up on a price oracle, how Flare does it, what does it provide. And we'll check up on FDC, which allows you to encompass a bunch of oracles in those two categories to execute deterministic queries to both external chains and external APIs and bring this to Flare. So that's the main point. So you have a dApp, it doesn't live in isolation, and you want to do something with it. And how do you do something with this non-isolated dApp that needs external information where somehow you have to get this information, and blockchain with oracles is usually the thing you want to use. And the next thing is you want to make sure that this is secure. And there are a few compromises that you need to take with oracles. So let's say I have black box, the oracle that is giving me price, and there are a few things you need to ask yourself about this oracle before even going into it. The first one is, what's the speed of this oracle? So that is important for some specific oracle. So if you have an oracle that says, is it raining at that specific location, the speed might not be that important compared to an oracle that is providing you a price of a certain very volatile thing. So if you have a pricing oracle for Bitcoin that is accurate to $1, you need this price to change very quickly compared to, for example, an oracle that tells you, is it raining in London or in Ljubljana or in Berlin, when if you do this every half an hour, that's going to be good enough. And when talking about speed, it's also important to consider two things. One is latency. So how often after the real world changes, how soon after the real world changes is your change of price refreshed on the blockchain? So how long is the time between a change somewhere else and when you can observe the change? And how often do you refresh this thing? So for example, let's say you have an oracle that is giving you a Bitcoin price. There's a big difference with having a Bitcoin price every second with 10 minutes of latency or having a Bitcoin price refreshed every 2 seconds, but with a latency of a few seconds. So those are the two things that are usually encompassed by speed. So how often the thing is refreshing, and how long does it take to get a new information after it emerges. Then the next one is the security. And since you're on blockchain, you need to take security very seriously. Why? Well, you can think of a security as a chain of choices. And every time you make a compromise in between, you're effectively decreasing the security of the whole thing. So if you want to develop your application on blockchain, you know that you want to focus on security, scalability, and the ability to be able to get this application to everyone that wants to use it without any censorship. That's great. Then you develop it. You use a lot of manpower to develop it. You make sure that everything works. You make sure that it is secure. And then if you choose an oracle that is not secure, all those previous steps that you've made are pretty much rendered worthless, because if somebody can impact your oracle, well, it doesn't matter how good and how bug-free your code is. If you're issuing a payment, if there's a sun, and anybody can just click a button, pay $5, and say, okay, their sun is London, your application is practically useless. So you need to make sure that if you go through all the hurdles of making your application on blockchain and you want to have it secure, you need to make sure that all these pieces in the puzzle, all these links in the chain leading from first user interaction to the final thing are properly secure. Then there's always the compromise of cost. So oracles cost different things. So it might cost you time, it might cost you development things, but there's sometimes also a cost to pretty much access the price. So you want to get the current price of Bitcoin on chain. Well, some oracles are kind of notorious for you having to pay a lot of this. Some oracles are relatively cheap. Some oracles are somewhere in between. But cost is something you need to somehow fit into your model. And then there's the maintenance. So how often does the oracle changes? Is there long-term support? Are you going to be notified about other changes? Are you be notified about the changes in the things that are affecting you. So are you going to be notified about the speed change, about the security change, about some cost changes? And at the end, there is ease of use. So how easy the Oracle is to use, how easy it is to use for your users, and are there any special features that the Oracle requires for you to use it? So do you need, for example, to get the Oracle to, I don't know, push some data? Do you need to prime it beforehand? Do you need to wait for it? Stuff like this. So those are all the things that you need to take into account before thinking about the Oracle. Okay, so you're now thinking about your application. You're now thinking about what you need to do with the Oracle. Let's see what you can do with this on Flare. So there are a bunch of oracles available. We're not going to name names because I was told not to, but the things you really need to consider, at least from my perspective, is that you have to choose the oracles that are good for you, and you have to choose the oracles that fit your profile. And if you are on blockchain, do remember that blockchain gives you security, and security is like insurance. You're paying for it, but you want to be paying insurance because when things go wrong, things can go wrong on a big scale. And for example, one of the big problems with choosing the oracles is if you go through all the hurdles of making your application decentralized, making your application available, and then choose a centralized oracle that sounds cheap, that sounds fast, but at the end, you can run into some big problems if the oracle fails, if it is not available, or if somebody is just trying to manipulate you. Or you can go through a bit more hurdles, but you're on blockchain anyway, and you can opt for a fully decentralized solution and be sure that all your work up to this point is not going to be hampered. So make sure that when you're checking the Oracle, you check all those properties and that you are always true to your cause, and you're always making sure that if you are selecting technologies to do something, if you are selecting technologies to specifically focus on some aspects, your sub technologies that you select should also support this. Okay, so let's see how you can use some oracles and what are the common uses of oracles. So we're going to focus on a price oracle. For example, let's say I want to know what the current price of Bitcoin is. Well, there are two ways to use this oracle. There are two most common ways oracle like this is designed. The first one is push oracle, and the second one is pull oracle. The push oracle looks like this. When you have, for example, on Flare, you have some data providers that are constantly pushing prices to chain, pricing to what we call so-called oracle contract, pricing to a contract that is always aggregating the prices, always keeping the prices there. And at any point, your smart contract, or pretty much any program that interacts with the chain, can query this oracle contract and get the current price. So oracles like this are very useful and very nice to use because you always have the most fresh price. The prices can be regularly refreshed, and it's very easy to use it because you just read the method. You maybe pay something, but you just read the method and that's it. There's no additional integration, there's no off-chain component, and there's quick access to the data. There are also some downside with it. The first one is that the data providers constantly need to push this data. They constantly need to update the data without knowing who's using it, which means that you can't have a huge amount of data, and that is very useful for things that change very fast, or for things that are used by a huge amount of people, a huge amount of applications. So Bitcoin price, that would be a good example. A price of a specific stock that trades on just one exchange, that might be problematic because you incur a cost every time you push this on. You have to make at least something to make this secure. Then you have to push it on chain, have it available on chain. And if you only read this once a year, well, it might not be worth it. The second one is the so-called pull oracle, where you request an update. Let's say, okay, give me an update to the Bitcoin price. And the data providers are listening for these so-called requests. They listen for them, they calculate an update, and they push this update to the chain. And when the update is on the chain, there are multiple ways of you using it. You can read it, you can get primed and then you read it, but usually this is done through some sort of a callback when the data providers push the price or the changed value on chain, and then execute a callback that calls your program, that calls your smart contract, and then the smart contract goes back to the Oracle, reads the price, and execute what it needs. Again, the system has a few upsides and a few downsides. One of the upsides is that this is relatively cheaper than the other way of using the Oracle. Why? Because you only have to update price thing when you need it, and you can also include some timestamps or some time-based updating when you don't update the price, for example, every 10 seconds, even if there's a request, because you can always reuse the old request. So oracles like this are useful for things that are one-off or don't happen that regularly, because you save a lot of pushing the price on chain because you only do it when necessary, but you have some sort of a latency problem because you first have to request the price and then you can use it. There's also a third solution when you do this somewhat in between, when you prepare all the necessary data off-chain and then push it on-chain and directly execute something, but making sure that data providers in the middle are doing their job. Okay, and let's see how Flare is solving some of those things. So one of the oracles we have on the network is so-called FTSO, so the Flare Time Series Oracle. What is it? Well, the Flare Time Series Oracle, as it says, it provides time series data. So it provides data about a series of data points that can be organized through time. And the easiest example to take a look at this is the price. So let's say you have a price of Bitcoin. Why is it a time series? Because for every point of Bitcoin price, you can assign it a time and say, okay, so today the price of Bitcoin was X, 1 second later it was Y, and so on. And FTSO, the Flare Time Series Oracle, is providing this price on-chain, on Flare chain that is directly available there, pretty much every block. So we have the scaling of FTSO from V1 to V2 has increased the amount of prices we can have on chain from a few tens to up to 1,000, while also providing them directly on chain. So you can always read Bitcoin price, Dogecoin price, XRP price, and so on directly on chain. And the main idea is, well, how do you make sure that this price is up to date, and how do you make sure that this price is correct? Well, we do this through the so-called FSP protocol, when each data provider submits their own price, so submits what they think that the price of Bitcoin is, and then we select a weighted median among all of those prices. So what does this mean? This means that if somebody says that the price of Bitcoin is $100,005, somebody else says that the price of Bitcoin is $100,003, somebody else says that it's $99,000, we gather all these prices in a list and select the middle of those prices and weight this by their vote power, so weight this by their stake. Why is that important? Well, we want to have a price that is close to the price that we think is correct, and we also want to have a system where if you submit a price that is way off, it does not impact the final price that much. And median is a nice example of doing this, because if I'm below half of the data providers, it doesn't matter if I say if Bitcoin is 90,000 or if Bitcoin is $1, I'm still going to impact the final price in the same way. So that's the FTSO. It takes the median of data sources. It takes the median of prices submitted by all data providers, takes it and says this is the final price. We also have incremental block level updates, which update the price every block, where data providers can submit small incremental update to the price, and the price then tracks the correct price. And after every minute and a half, we also have this FTSO scaling price when you have a big price collected through the consensus through all the validators. So this was just released. So it was released this year. It has been alive on Flare and Songbird for quite a while, for almost half a year. And during this time, we've seen quite a lot of very good behaviors. So because we're sourcing the data from multiple data providers, what that means is that even if a data provider goes down, even if an exchange where the data providers are sourcing this data goes down, other data providers quickly adapt. So even during the times where the exchanges were down, the exchanges were submitting bogus prices, the exchanges were not giving out any prices at all because their APIs did not work, or when there was a depeg on the USDT, even at that point, the data providers adapted immediately, and instead of providing bad prices or depeg prices, they immediately provided the median that was good. So that's the flare time series oracle. So providing you a price every block and then providing you anchor prices through the commit reveal scheme to make it safe. Okay, importantly, it supports up to 1,000 different data feeds that you can read directly on chain. And you can do this either at the block level and you can read them, so you don't need any off-chain data, or you can have scaling prices with full security when you know that the full security of the network has been behind selecting the price, so the full median, and you can read this via full security on-chain and off-chain and use the off-chain component to verify this on-chain. Okay, and one of the main things when we were moving from FTSO V1 to V2, so when we were increasing this thing, is how to keep this system efficient. So when you are on blockchain, you always have to think about how to make things as efficient as possible and how to make them as easy to use. So to do this, we moved most of the computation about those prices off-chain to be performed by data providers. So most of the median computations are performed by data providers. They only submit small pieces of so-called Merkle roots to the chain so that we don't have to save all the prices on chain. We just have to save a single checkpointed price, a single checkpointed Merkle root on chain, and then you can use this to verify the price that you need to do. Why is that important? Well, as you know, the space on chain is highly limited, and you need to be careful about both your validators, you need to be careful about your validator set, you need to be careful about how much infrastructure you require the validators to run. And to do this properly, we wanted to make this as efficient as possible. So instead of pushing all the data on chain in the FTSO V2, what you can do is you just have a Merkle root on chain that allows you to verify the price. And each time you need the price, you compute a small and very efficient proof on off-chain and then provide it on-chain, and on-chain you validate all of this. What this allows you to? Well, this allows you to have a nice chain without any space bloat that still gives you all this information under the same security assumptions. So that's an important thing. You want to have a protocol that provides you a lot of prices while also making sure that your chain works, is efficient, and does not cost the validators too much. Because again, if you cost the validators too much, you might have a problem with onboarding new validators, and that is also bad for the chain. So you want to have security on all the levels, from the validator set to the data acquisition set to the verification set. Okay, just a few more details. So what this does, well, Merkle root is deposited on chain, and then you can easily verify this price directly on chain. This is low cost. It incurs only minimal gas prices, nothing more than just reading a simple slot from an EVM chain, and it's available to anyone. So anyone can listen to this, anyone can verify it, and even if somebody provides you with the price that is wrong, you can easily verify that this price is not correct. So you can't be fooled into using an old price. You can't be fooled into using a bad price. You can always check that the price is correct, and you have the whole blockchain and the whole FTS system to assure you that. Okay, so let's see what does this exactly mean. So we can always check the Flare Systems Explorer. So Flare Systems Explorer allows you to check what's happening with the whole Flare system protocol, FTSO and FDC, and always see what's happening there, what the prices are, what the data providers are submitting. So I already have it open. So you can go here. I'm just going to refresh and get the latest price. And well, let's see what's happening to Bitcoin. And here, if I go and check the last 30 minutes, you can see what prices were submitted by our data providers in all of the last 30 minutes, how many of them submitted, what happened to the anchor feeds, what happened to specific feeds, and importantly, what you can see here, you have a detailed information about this specific voting epoch. So you have a detailed information about these specific voting epochs, what the data provider submitted, and what happened. Important thing in keeping the whole system functioning and the whole system working as intended is to make sure that there are proper incentives to make data providers submit correct prices. So how do we do this? Well, like I said before, we select a median to say this is the correct price. And after we select this median, we reward the data providers that were close to the median a bit more than the ones that were way off the median. The closer to the median you are, the higher the reward. the further off you are, lower your reward. In this way, the data providers are incentivized to always make sure that they provide good price and to always make sure that any anomalies happening in their price sourcing algorithm are quickly discarded. So like I said before, you want to make sure that when an exchange is misbehaving, you discard it from your prices and don't submit it, because you want to be in this median and get some sweet rewards. And like with everything, the incentives are really important, and we're constantly working on improving the incentives, making sure that they match, and analyzing that the incentives are really guiding us towards the proper Bitcoin price. So if we're looking at this Bitcoin price in here, so you can see that the data providers are pretty much attempting to get the price right up to $1. So even with Bitcoin, which is worth $100,000, the data providers agree to practically $1 without any collusion, by trying to get closest to the median, by trying to source data from different quality data sources, from different exchanges, approximating what the volume is, approximating what the future price might be, and getting directly spot on. Okay, so you can always see different prices here. You can check your favorite data provider and so on. And that was one of the oracles. So the so-called probabilistic oracle, when you can check things that are moving, things that can be very close. The second oracle we provide is so-called Flare Data Connector, or FDC. What it does, it allows you to issue deterministic request. So what does that mean? But it allows you to connect to other chains and see what's happening on other chains. So you can say, okay, I want to know full information about this Bitcoin transaction. The FDC, so you issue a request. This is a pool-based oracle. You issue a request. The FDC computes this request, gives you the full information back, together with the proof that this was really attested to by the whole set of attestation clients, the whole set of validators, and then you can use this proof, use this data on-chain. And with the current status of FDC, you can connect to other chains, you can connect to Web2 data sources, and you can connect to other non-EVM chains, Bitcoin, Dogecoin, XRP Ledger. You can connect to EVM chains. You can connect to Songbird. You can connect to Flare. You can connect to Ethereum, and you can also connect to Web2 data sources whenever you can create a specific deterministic attestation request when every validator sees the same thing at that time. How do you do this? Well, it can be a bit complicated, but we're going to take a look about how to create all this in one of the further exercises. Okay, so like I said, we support non-smart contract chains, so specifically Bitcoin, Dogecoin, and XRP. You might know that some important things about those chains are coming very soon. And we also support EVM chains, which allow you to relay not only just the data about specific payments, but also allow you to relay data about specific events. What that means is that your dApp can not only use an Ethereum payment, but it can use information about a payment on Ethereum made with USDT. It can use information about something on Ethereum happening on a Uniswap, a swap happening, an NFT being minted, an NFT being burned. Flare can observe all this, use this data on Flare, you can compute on top of it, you can be sure that this data is correct, and since then this is a smart chain, you can relay data via any bridge you want, or you can act upon it. Okay, and one more thing about the FDC. So as long as your attestations are deterministic, so as long as you can make sure that you can connect to, that anyone can connect to your API, or anyone can pre-process and post-process your API in a proper way, we also support custom type definitions. So in the last few hackathons, people were quite excited about this, and we got some nice submissions where people were able to use the specific JQ FDC type to connect to either closed data sources, either to weather data, either to some data related to insurance, or relay data from other prover mechanisms for ZK. Take this data from other chain, take this data from custom API endpoints, prove it via FDC, so that you don't only relay this data, but you know that this data is in fact available at that specific URL with that specific input. Take it, move it on chain, and then on chain they were able to do a bunch of things. So as long as the thing is deterministic, as long as you know that you can ask a yes/no question and get the same response from all the validators, you can be sure about this and you can move this to Flare. Okay, there are a few things we might need to talk about, which is so-called bad data. So as we told the oracles, you need to make sure, again, security is paramount. You need to make sure that your oracle is really secure, because there are some problems that are specific to blockchain. So let's say you have an oracle that's problematic. Let's say you have an oracle that is a bit too quick and says a specific Bitcoin transaction has happened. You push this to Flare, or you push this to your favorite blockchain, to whatever you want to do. You do something on top of this, and then you see that, well, there was a fork in Bitcoin or something bad has happened, and you were too eager to prove it. That can be a big problem, because you can't roll back your transaction on another chain. That's why on Flare, we made sure that all those types of things, when there's a small problem with this, when you can have a problem with transaction being confirmed too soon, for example, on EVM chains, you want to know how deep the transaction is inside the stack of Ethereum blocks. We allow you to configure this security. So we allow you to also issue a specific query to the FDC to say, okay, give me this transaction, but make sure that it has been at least X blocks sold. So make sure that it has been included in at least Y blocks or something like this. So we have to make sure that all these steps here can be taken, and the dApps can configure this security to how much they want it. When developing this, you also need to make sure that you take care of the experience both of the developers and take care of the experience of the end users, because as we know, waiting can be problematic, specifically for end users who want their transaction to go through as soon as possible. But as always, you're on blockchain, so try to err on the side of caution, just to make sure that you're not issuing things too fast, you're not doing some stupid things, and you also make sure that you also make sure that the security is really paramount. Okay. And just a few words about how we really do this, so how we really make things work. So to secure all these things, we bundled the roles. So what does that mean? We said the following. So instead of validators being just validators on the Flare network, so instead of validators just running the validator nodes, they also have to run their own data provider. So validators also provide this pricing data. They consistently update the prices on chain. And in the case of FDC, they also have to run their own FDC clients and be able to verify external transactions happening on other chain, and soon also on Web2 protocols, and make sure that they also verify them. So why is that important? Well, if you have an oracle that is detached from your chain, you always have a problem with how much how high the security of your oracle really is. In our case, that's very easy, because we're securing the whole chain, the whole oracle system, by the same security assumptions as we have for the securitization, for the securement of specific transactions. So the same people that are validating your transaction, the same people that are mining new blocks, are also making sure that you always have correct Bitcoin price information, and you always have correct information about Bitcoin transactions. And as we are on L1, we can be a bit more creative with this, and we can push a lot of things to validators, and we can also get a lot of security assumptions out of this. So we can know that they're always giving us best price, and we can tie this together with incentivization to make sure that all these parameters are properly secured. Okay, so, and if you want to check the latest status of the FDC, you can go to the Custom Systems Explorer, which is an explorer for testnet. Check the FDC tab and see what's happening, for example, with transactions for this Bitcoin. So we can check a specific voting round ID. And just wait for a second for it to load. Okay, that's still the current voting round, so it's still loading. Let's take an older one. Okay, that's still 0.38. Okay, that was just issued. Let's go back a bit. Somebody issued a bunch of requests. Okay. Let's just take that one. It should update immediately. Okay, so new transactions are still coming in. While we're waiting for the full consensus, let's just check the test BTC transaction. So this is, for example, a request that is issued to test BTC because we are on testnet. with some mic, and this is the full information about request. So if I were to run the coder on top of this, it would say that somebody is confirming that Bitcoin blockchain has reached at least X blocks, and is also including some verification code on top of it and so on. So this is one of the example of these deterministic attestations when you can say, okay, can you prove exactly this thing? And now all the validator set, so this is where it is included, the whole validator set at the end will say yes or no and say, okay, we're confirming that this has indeed happened, or we're saying, okay, no, it hasn't happened. Okay, and you can see, so the round has ended. So this is a test network, and all the transactions that were issued, the whole validator set has said, okay, yes, indeed, we're confirming that this required test attestations did happen. And once this is completed, the validators take this, put this through the commit reveal scheme, through the bitvote scheme, commit the Merkle root, sign it, put it on chain, and then you can easily verify your information and have it available whenever you need it. Okay, and that's the FDC. And like I said before, so we're leveraging the validator set. Once again, why is that important? That's important because you have these bundles of stake, and you know that most of the value that's securing the network is also securing the data. As you have data that is more and more secure, you can be certain that your chain is also more secure, and all the applications participating in this chain are also more and more secure. Okay, and just a few words towards the end. So not to be fully academic. So what are oracles? Why do you need them? And now what you can use them for. The main idea is, you know what you have, you know what's available. Here's the blockchain, here are the resources. Now think about things that were currently impossible because you couldn't get access to a proper data source, you couldn't get access to a secure data source, and you couldn't get access to the important thing, a secure connection between your data source and the chain at the end. So this currently powers a few proof of concept examples. So on Songbird in July, we had a really nice decentralized Olympic Games prediction market where FDC was used to source multiple data sources about a specific Olympic football match or a specific Olympic match in multiple sports, determine the winner, push the attestations about this winner on chain, and then have the whole system agree about this information. So not only one validator, but all the validators issued the same query, issued the same post-processing request, arrived to the same decision and said, yep, we are all confirming, for example, that South Sudan has won the game against Puerto Rico. What does this mean? Well, this means that you can have a prediction market on chain where you now don't have to trust the one that is finalizing it. If you can write down the conditions under which this prediction market gets finalized, if you can create a deterministic request for this, you can have the validator set automatically finalize this, and you can have a smart contract finalize the final prediction without needing to have an additional person, an additional committee in between. So you can have a bet when you don't really need to trust your bookie to do something correct. You can issue a bet, you can issue the code that is finalizing it, and have the data connector do all the rest. You don't have to trust anyone. And of course, this also powers F assets. So why is that important? Well, if you have a non-smart chain, there is no way to have full information about what's happening. I mean, there's no way to have full control about what's happening on non-smart chain in a fully decentralized way. Well, unless you have FDC, and if you develop a nice system around this, like with F assets, you can always make sure that the FDC is controlling the agents on one side to not do something that's malicious, get this data in a decentralized way to Flare, and then settle everything on Flare. So again, what you're doing, you're opening a bunch of new possibilities to make new things, to develop new dApps, to pretty much use the external data that people want to use. So most of the things are happening outside of blockchains. You want to use blockchain for those specific security-aware things. The rest of the things, the rest of the information should come from the outside. Okay, so that's mostly it. If you want to learn more about Flare, if you want to learn more about when new things are coming out, come join us on Twitter, come join us on Discord. There's a dev hub you can check. Come and play and build on Flare. And now for the final part, there's Q&A. So I think I already have some questions. Yes. And as always, join the fun. So scan this QR code, answer some questions, and you might get a nice chance to win a full set of Flare merch. So the t-shirt, the hoodie, the cap, and maybe something else. Okay, so we have some questions. One question is, how does a non-numerical oracle predictions get their median? Like the example you said, sun raining on a city. Is it pure 50.1% weight? Yes. So there's the difference between when you want to use FTSO, when the median is a good final selector of the what a good final answer would be, and the median is good for things that you can easily order. So prices. If Bitcoin is priced on $100,000 or 99.999, those two things are very close, and you don't even, it doesn't really matter that much which price you select. Okay, if you're really on the fence, it might, but most of the time with things that can be ordered, if you're very close, that's almost good. And for the sun, you might not have chance of sun. You might have, okay, we're going to define sun as less than X millimeters of rain. So that's one thing when you can have a median and say, okay, please submit what do you think the amount of rain is, and then take the median of this rain and set this as the median. The other thing, when you might not go toward the median, is to use the FDC and to have some post-processing. So you would say something like, okay, so take the weather.com API, and we consider these 5 responses to be sun. And then you take one API and check if they responded sun. And you take the second API and check if they responded sun. And you take the third API and check if they responded something that they consider sun. And then combine this maybe by a majority vote. So median is good for purely numeric data sources, for things that are yes, no, or have multiple choices that are not close to each other. You would want to have something else. You would want to use an FDC and have some post-processing on top of it and say, I consider those a yes answer or those a no answer. So it's very similar to machine learning when you have regression versus classification. So if you want to have things on a nice line and say, okay, it's almost this number, then the median and FTSO is fine. If you want to group them in some buckets where there's nothing between the bucket, you want to go towards the FDC. The second one is, what are the key differences between Flare's Oracle technology and other Oracle solutions like Chainlink? Well, like I said before, so the main difference is that Flare is an Oracle network. So oracles on Flare are directly enshrined inside the network, and each validator is also has to be a data provider, an Oracle provider. You can't be one without another, which means that there is a whole different level of security underneath it. So we're not building on top of another network, we're building an Oracle that cannot be decoupled from the network. So the main difference is we are focusing very, very strictly on security. That's the core difference, but there are also some other differences. When we have a different refresh times, we have a different way of finalizing things. And also one important thing with Flare is that we allow you to query so-called passive data sources. So with FDC, you can query a data source even if this data source does not actively participate. So Bitcoin network does not actively participate in pushing the data to Flare. We have the validators who are observing Bitcoin network and then get data and push it to Flare. What that means is that it's much easier to get new data sources without their cooperation, or it's much easier to get data sources that can't really cooperate because the validators can source them. You don't have to talk to the Bitcoin chain and say, please, can you please provide us this data? The validator just observe it and push it on. So one of the important differences is that we source data from different sources, and again, through the whole validator set. So it's not just somebody is saying, okay, I'm going to execute this function for you with this data. No, it's the whole network going somewhere else instead of you to check something. How does Flare ensure the security and reliability of data powered by its oracles? Well, like I said before, so by making sure we properly incentivize data providers to provide good data. So most of the rewards for being this bundled validator on chain come from the fact that you validate block properly, but the huge majority comes from the fact that you are close to the correct price in the FTSO system, so that you're close to the median, that you're close to the things that should be that are at the end selected as correct answers. So with the FDC, you are rewarded if you provide the correct FDC Merkle route. You are rewarded if you provide the correct answers to Bitcoin queries. So we make sure that this data is secure and reliable and can't be censored by making sure we properly incentivize our data providers and by making sure that data providers are staked in the system. Are there any specific tools or libraries that developers should familiarize themselves with when starting to use Flare oracles? So I would suggest going to the Dev Hub. We are currently updating our Hardhat starter pack, which includes all the necessary libraries to connect directly to Flare, so you don't have to get the addresses, you don't have to copy the interfaces to do all this. So I would say Dev Hub and Flare's GitHub are main two things that you should familiarize yourself. If you already know EVM, if you are starting with blockchains and EVM, maybe the easiest thing would be to start with some initial EVM tutorials. You can also start with our previous academy when we started completely from scratch, created a smart contract and immediately connected it to Flare, and then go to dev.flare.network and start from there. What is the roadmap for Flare's Oracle technology? Are there any upcoming features we should look forward to? Well, so FTSO, this year we've scaled FTSO from version 1 to version 2 to allow you more data, to have shorter latencies, to have higher refresh periods, and so on. So that's one thing that we did. FDC is coming out very soon, so you can see it being tested on Coston. If you maybe check what's happening on Songbird, you might see something new. And there are a bunch of things coming out within FDC when we're developing our own specific but generalized attestation types, when you would not be only able to say, okay, what's happening on Bitcoin and get a Bitcoin payment, but you would be able to check what's happening on Web2 data sources, what's happening on specific external machines, maybe execute a specific instruction, and so on. So I can't really tell you anything specific, but a huge improvement to this, being able to not just execute a simple query, but being able to run a whole computation somewhere else is coming pretty soon. So stay tuned. So I think that's about it. Thank you for joining. Thank you for listening. I hope you had fun. See you next month when we're going to take a look at some other Flare technologies and dive deep to see what's happening, to be able to build more, get more things. And yeah, stay tuned, because a lot of things are coming out right now. You can get a lot more information. And like I said before, so we're slowly building the network. New things are coming out, and always when you're thinking about the blockchain thing, when you're connecting blockchain to other things, to other data sources, how does adding this data source allows me to build something that I wasn't able to build before? So if I have a simple futures platform on a chain without a pricing oracle, I can't do anything. If I have a pricing oracle, now this futures application can really do something. But if I have a pricing oracle and the ability to connect to other chain, can I add something more? If I have a pricing oracle and the ability to listen to Ethereum, to listen to events emitted by Uniswap, can I do something more? If I can listen to weather data, can I do something more? So is there more is there more things that people would like to use blockchain for, but weren't able to do until now, when you can really give them access to this data, use the external data, and then compute something on chain? Okay, thank you.